All right, this video is going to show you how to add and subtract rational expressions. So a rational expression is anything that can be written as a fraction. So we're going to start with just our first example is just subtracting fractions. And then we're going to go into some algebraic fractions, which is what a rational expression is. So if we look at this particular problem, we need to have a common denominator to be able to, before we can add or subtract. We cannot cross cancel, that's only multiplication. So if we look at 3 and 15, 15 would be my common denominator. It's a thing that both so 3 will go into 15 5 times. So 3 times 5, we're going to write an equivalent fraction. So 2 times 5 would give me 10/15. 10/15 reduces to 2/3. I don't need to do anything here because I already have a 15 in the denominator. And then I will simply subtract my numerators. So 10 minus 4 is 6, and 15 is my denominator. Now, at this point, I can simplify it. I have a common factor of 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. So my answer for that is 2/5. All right. So now let's look at our first algebraic fraction. So we have 3x over x plus 7 minus x minus 7 over x plus 7. So the first thing we need to do is check out, do we have a common denominator? And we do, so that's excellent. So that denominator is going to be the denominator for our answer. And then we just will go ahead and subtract our numerators. So 3x minus x minus 7. Now we have to be super careful because I'm subtracting that entire thing. So it's like putting a -1 there. So that really says 3x minus x plus 7. And so my answer would be 2x plus 7 over x plus 7. Now, I cannot cancel the 7's and the x because this is a package deal. It is a binomial. And so that is my answer. All right, so now let's look at one that has a denominator that is not the same. So let's go with example number 3. So example number 3 is 6x over 3 plus 7 over 15x plus 3. So based on what we did before with finding a common multiple or finding a common denominator in the video before, we need to do that. So first thing we're going to do is we're going to write out our prime factorization for both of these expressions. Well, 3 is just 3. And 15x plus 3, I could pull a 3 out of that, and I'd be left with an x plus 7. Or x plus 1, my bad. 5x plus 1, let's try that again. 3 times 5x is 15x. 3 times 1 is 3. So now I need to find my LCD or my LCM. Lowest common denominator or least common multiple. All right, so if we look for our LCD, we have a 3 in common. So we definitely need the 3. If I had to name the GCF, it would be 3 in this case. So I've taken care of the 3, and now I need the 3, and I need a 5x plus 1. So I'm going to throw in a 5x plus 1. Writing them out like this will help you when you go to rewrite the equivalent fractions. I highly encourage, if you're doing this for a test or something, I'd like to see this so that I can tell what you did. All right, so that's my LCD. So I'm going to just leave it in that form. 3 times 5x plus 1. And then I have 3 times 5x plus 1. Now, this is that whole denominator, so I don't need to do anything different. 3 is missing the 5x plus 1. So that's what I need to multiply the top and the bottom by. And so I end up with 6x times 5x plus 1. And now I'm going to simplify. Well, I know my denominator is going to be 3 times 5x plus 1, or I could write it as 15x plus 3. But honestly, I'd leave it in factored form because if I can get the numerator to factor into one of these two factors, I could cancel it. So we usually don't multiply it out at this point. So I end up with 30x squared plus 6x plus 7. Now, 5x plus 1, I don't believe that is going to be a factor. It would have to be 7 and a 6. Yeah, that's not going to do it. So that is my most reduced form. All right, example number 4. I'm going to write this example down, and then I want you to pause the video, and I want you to go ahead and work it. We have x plus 7 over x squared plus 13x plus 42, and I'm going to subtract from that 10x over x squared plus 8x plus 7. So pause the video. I want you to find the least common denominator and then hit play. All right, so I've listed my factors. My GCF in this case is x plus 7, so I need one x plus 7. And what am I missing? I'm missing an x plus 6, and I'm missing an x plus 1. So that is my least common denominator. So now we need to rewrite these. So this guy was x plus 6 times x plus 7, and this one was x plus 1 times x plus 7. Writing those there helps me be able to see what I'm missing. So my denominator is x plus 1, x plus 7, x plus 6. I'm going to rewrite my fractions. X plus 1, x plus 7, x plus 6. All right, so this fraction, what is the denominator missing? It looks like it is missing an x plus 1. So I need to multiply the bottom by x plus 1, and I need to multiply the top by x plus 1. It is super important that you show your work here, because if you make a little tiny error, but I can tell what you're doing and you have the right idea, you lose minimal points. If I can't follow any of it, then you would have to lose all of the points. So this guy, we got an x plus 1 and an x plus 7. We're missing the x plus 6. So we're going to do minus 10x times x plus 6. All right, so now it's time to simplify. So we're going to have this multiplied together would give me x squared plus 8x plus 7. We're just going to put that all over our denominator. Again, leave your denominator in factored form. That helps us later. Now I'm going to go ahead and throw that negative sign with the 10, so that helps me. So I'm going to put plus negative 10x squared, and then minus 60x. So I just pass that negative 10x out. And now I need to simplify this from here. I get a negative 9x squared minus 52x plus 7 over x plus 1, x plus 7, and x plus 6. Then your goal would be to see, can I possibly simplify this? Are any of these factors of this guy? 9, 3 and 3, and I have 7 and 1. There's no way I'm going to get a 52 there. So at this point, I would just be finished. It could be written like this, or sometimes you'll see that negative out front, and that's going to switch those signs on that numerator, but not mess with your denominator at all. So I would leave the denominator still in factored form. So let's talk through our steps. First step is check to see if your denominators are the same. If they are the same, add numerators. Okay. If they are not the same, Then we are going to find an LCD. Okay, once we find our LCD, then we're going to rewrite fractions with the LCD. Once we do that, we're going to add or subtract the numerators. We're going to simplify. And then check to see if numerator will factor and cancel. And that's it.